So today's lesson, we're going to look at the electromagnetic spectrum, and we're going to really dive into waves. So let's just start by looking at page 5 of our reference tables. This is our electromagnetic spectrum, and we've already seen this in a previous unit, so we're going to dive into it in a lot more detail. So the electromagnetic spectrum, we learned back in our chemistry unit, these different types of waves are caused by electron movement. We have radio waves, which have longer wavelengths. And then on the right side, gamma rays have shorter wavelengths. And then we have all of the other different types of wavelengths in between. Let's use the visible light, red and violet, where red has a longer wavelength and violet has a shorter wavelength according to our electromagnetic spectrum. So let's prove that. So I'm going to draw a red and a blue wavelength. So here's a red and a blue wave, excuse me. All right, so here's my red wave. Now, if we were to take our wave and draw a dotted line through the center, okay, the wavelength and it has this symbol, and the wavelength is defined as the distance of one wave. So in this red wave that I've drawn down here, we have a couple of waves. All right, the wavelength goes from the top of the point to another top of the point. Okay, so we call that the wavelength. And each one of these top parts is called a crest. Okay, so that's the top of the wave. A wavelength can also be measured from the bottom to the bottom. And we call this the trough. All right, that's the bottom part. Now, frequency, and we're going to use an F for frequency. This is the number of waves in a given time. So to count our waves, essentially, we have one up and one down. One up and one down is a wave. So there's one wave, an up and a down is two waves. So I have two waves here and a partial, all right, but let's just stick with the two full waves. So I have two waves, so I have a fairly small frequency, but let's look at a blue wave. I'm going to start with my dotted line just because it makes it easier for me. Okay, so here's the blue wave. The wavelength goes from the top to the top, the crest to the crest, or trough to trough. What do we notice about the wavelength of the red compared to the wavelength of the blue? The red has a much larger wavelength than the blue. So the red has a larger wavelength. The blue has a smaller wavelength. All right, let's count our waves. One up and one down is a wave. So that's one wave, two waves, three waves, 4, 5, 6, 7. I have 7 waves. So when we look at the number of waves, the blue has more waves than the red. So the frequency, how many waves we have, the frequency of the blue is larger than that of the red. So we put red has a smaller frequency, blue has a larger frequency. So what does this show us? A larger wavelength has a smaller frequency. That is an inverse relationship. A smaller wavelength has a larger frequency. So wavelength and frequency are related by an inverse relationship. Now let's look at the energy. And I'd like for us to think about energy in terms of an ocean wave. So if you've ever been to the ocean on a calm day, waves come through. Periodically, we have less waves. They come through, a wave comes through, then another wave comes through, then another wave comes through at some point. When that ocean is not as calm, we have waves coming back to back to back to back. A wave hits, a wave hit, a wave hits, a wave hits. When you're swimming in the ocean, which one are you more likely to get knocked down when that wave hits you? All right, it's more difficult to get past that wave break in the ocean. And that's when they're coming in one right after the other. And that is because frequency is related to energy in a direct relationship. So a larger frequency has a larger energy. So I'm just going to draw an arrow for the energy increases. A smaller frequency has an energy that decreases. A smaller energy. All right, so frequency and energy are directly related. One more thing. We can also find the period. All right? The period is defined as the amount of time it takes for one wave to pass. All right, so period would be the amount of time it takes for one wave to pass. So how long does it take for this first blue wave to pass? And then the second blue wave? Or if we were to look at it in terms of the red waves, the first red wave and then the second red wave. All right, so period is our amount of time. Now, all of this is going to be important in our electromagnetic spectrum because a radio wave, let's do an example. Okay, let's say a radio wave and a microwave. All right, and we want to determine which one has the largest energy. All right, so that's our question. Does the radio wave have the largest energy or the microwave? So when I look at my electromagnetic spectrum, I notice radio waves have a longer wavelength than microwaves. So radio waves have a larger wavelength. Microwaves have a smaller wavelength. Now we're going to energy. A larger wavelength has a smaller frequency. A smaller wavelength has a larger frequency. And now frequency and energy are directly related. So a smaller frequency is a smaller energy. A larger frequency is a larger energy. So the largest energy would be our microwave. All right, so that's the answer that we would put. And we can determine all of this information based on this electromagnetic spectrum. The fact that we know the wavelength is larger with the radio waves and it decreases as we move to the right. Now, you may have been able to go direct from wavelength to energy. And if you intrinsically recognize that since smaller frequency is a smaller energy, and if frequency and wavelength are inversely related, energy and wavelength are also an inverse relationship, that is okay. All right. If you are able to see that and go from wavelength to energy without going through frequency, that is fine. I like to, in my head, I just always go wavelength, frequency, and then energy. All right, get you a system that works. All right, this way I get all three. So regardless of what I'm asked for, I'm able to find it. So when we look back at our electromagnetic spectrum, this part right here is our visible light. So we see all the different colors of the light. Red does have a longer wavelength. Violet has a shorter wavelength. All right. And again, what causes all of these different wavelengths? A review from our chemistry unit, and that is the movement of electrons.